G'day and welcome to the first in a series of videos on the compound and double angle formulas. We're looking at trigonometry, again, chapter 14D in this case, and I'm going to spend a bit of time creating some formulas. Now you don't really need to follow all of this creating the formulas. If you want to skip through to the end of the video and just have a look at the actual formulas and then apply those, then that's okay. But it's fun to look at these formulas. It's fun to know how they've come about. It's amazing. It's like magic. You can go up to someone at a party and show them, and they'll be bamboozled and love you forever. So here we go. I'm going to make one of these formulas, one of the trig formulas. I'm going to get the unit circle here. I'm going to call this point B and this point C over here. Now at this point B, I'm going to label this angle V, which means therefore it has an x value of cos V and a y value of sine V. And I'm going to call this angle here U, which means this point has a x value of cos U and a y value of sine U. Now, because this angle here is U and this angle here is V, therefore this angle is U minus V. Okay, and now I'm going to prove a couple of things. I'm going to get a triangle and then I'll find out what the length of CB is. I'm going to use Pythagoras, so I've got this line here, I've got this line here, and I've got this line here. So CB squared is equal to the distance in the x values, which will be cos V minus cos U, just using the distance formula, this one minus this one, all of that squared, and then I'm going to add sine V minus sine U. Okay, and now I'm just going to do a little bit of expanding of this. I'm going to get cos V squared minus 2 cos V cos U plus cos U squared plus, run out of room, sine V squared minus 2 sine V sine U plus, again, sine squared U. Okay, now I'm going to notice a few things in here. I'm going to notice that cos squared U and sine squared U is there, and I know that when you add those two together you get 1. And I've got cos squared V and sine squared V, again using that formula we used the other day, that equals 1 as well. So I end up getting 2 minus 2 cos V cos U minus 2 sine V sine U. Okay? Isn't that great? Good. I'm going to stop there. Now I'm going to rotate this triangle, or this section of the unit circle, down to the right so it meets the x-axis, and do a bunch of other things now. So the same part, I've moved it down to there just so you can see it all together. There we go. So that point B is now where the point A is, and the point C is now where the point P is. Now what I've got is I know that this angle in here is going to be U minus V, because that's what we had before. That angle is U minus V. So therefore P has the coordinates of cos U minus V and sine U minus V. Now I'm going to work out what PA squared is. The reason I do that is because PA squared is exactly the same as CB squared. Yeah, it's the same line, same distance, I've just rotated it. So I'm going to work out what PA squared is now. So that is going to be, this coordinate here is 0, 1. So I'll do the x coordinates first. Oh, sorry, not 0, 1, 1, 0. My mistake. The x coordinates first, so that means 1 minus cos U minus V squared plus 0 minus sine U minus V squared. Oh, I need to tidy that up a little bit. I'm running out of room. Okay, now I'm going to expand this and I'll get 1 minus 2 cos U minus V plus cos of U minus V squared. That 0 minus is going to disappear. It's just going to be plus sine U minus V squared. And again, I look at this, I add those together, that's just 1. So I get 2 minus 2 cos u minus v. I'm almost there. I've almost proved my my rule. So I'm going to make PA squared equal CB squared. So I get 2 minus 2 cos, actually I'll do it the other way around. Oh, it will be the same. 2 minus 2 cos u minus v equals 2 minus 2 cos v cos u minus 2 sine v sine u. What do I notice? These two cancel, just minus 2 on both sides. And now I'm going to divide everything by negative 2. And I get cos of u minus v equals cos v cos u minus, plus, because I divided by negative 2, sine v sine u. And that, ladies and gentlemen, is one of the rules that we need to know. So if you didn't understand all of the stuff that I did before, you just need to know this formula here. But how much fun was it knowing all that stuff? It's great. Now, the application for this, or a way that you can use this, is that you could make u and v particular values. So, for example, we could say cos of 15 degrees. What's that? We don't have a calculator, and we also don't have our special triangle. Well, the special triangles don't cover 15 degrees. But what I could do is I could say that that is the same as cos of 45 minus 30. Notice now that's the same as our formula up here. So that has to be the same as cos of 30 times cos of 45 plus sine of 30 sine of 45. I think I might have mixed those around. Actually, it should be 45 and 30, but still, I think you get the picture. Now I can go to my special triangles and know all of those things. Cos of 30, root 3 on 2. Cos of 45 is root 2 on 2. Plus sine of 45 is root 2 on 2. And sine of 30 is a half. So that ends up being root 6 on 4 plus root 2 on 4. So root 6 plus root 2 on 4. That's what cos of 15 degrees is. Now, just to confirm, I'm actually going to go to my calculator. Okay, and I'm going to type in cos of 15 and the degree symbol, otherwise it'll think it's in radian. And I get that, which, if you have a look, is the same as mine. If you expand this out, you get root 3 times root 2, which is root 6, and then 1 times root 2, which is root 2, and that's exactly what I had over here. So, this is the part where you can skip right to the end if you want to. If you want to know all of these formulas that you can derive, here they are. These are called the compound angle formulas. The one that we've proved is number 2, cos u minus v. You can prove all of the other ones if you want to, or I can show you them another time. Check out your textbook. But otherwise, we need to commit to memory all of these formulas in here. The reason that they're good to know, by memory, is that often you'll get asked to prove something and you don't know which rules to use, and knowing all these rules, that are just in your tool belt to whack out at any time, is a great way of doing it, rather than having to check the sheets all the time, and it just take you a lot longer to work it out. So those are the rules that you need to know for this particular topic. There are a bunch of other rules. They're called double angle formulas, and that will be in the next video. So thanks for watching.